Hey guys, welcome back to lesson 111. Now, before I start, I might have to tell you, there might be a reason for me to go over investigation 11? 11, I think it is. Let me check. Investigation 11, but I don't know yet. If I see that it's going to come up in a test, I will go over it. If not, I'm just rather go over it. And you know that even though some of you complain that I don't really do the investigations, it has never really hurt you for a test. For the lessons and for the homework, they barely do investigation questions in the homework, and that's why I don't go over them, because I know what's the stuff that is coming in. I mean, I have taught math from 6th grade all the way to 10th grade, and I've actually also owned the 11th grade book. Not the school, me. I actually purchased it because I have tutored 11th grade math, and I also taught 1/4 of it when Professor Toman had to go do his surgery. So I know what I'm talking about. This is one of the reasons that I don't understand why students actually think that I'm trying to just skip over them because I'm trying to fail you or, do something that is not good for you. No, trust me, I know it's coming. That's why I don't do them, because most of them are a waste of time. And later on, we actually get to a lesson that explains it way better than the investigations. And that's one of the reasons I don't do investigations. I just don't like the way that the book explains things in the investigations. They do a better job to do it in a lesson than in the investigation. And that's why I would rather do a lesson than an investigation. But you know that every once in a while I do them. Like I did in 6th grade, I obviously always do the one for graphing because everybody needs to learn how to graph. And then when you do first probability, I do it. Maybe interest or something like that, I do it too. But other than that, you don't really have to know about it. So only if it comes up in it's going to come up in a test. I might do a video and I will let you know. But understand something, because we kept on going without taking tests. We are ahead in lessons. And so we have to catch up with tests. So you just took 19, I think. So CT20 is going to be next, but CT20 is supposed to be taken after lesson 100, if I'm not mistaken. And we're already in lesson 111. So we are way ahead in lessons than in tests. So if it's coming up in a future test, it would have to be CT23. So you have a long time. So don't worry about it, because it cannot be CT22. CT22 only comes out until lesson 110. And then we're supposed to do the test and then the investigation. I think that's the order what they do it. And so if it comes up, it should be in CT23. It might come up in CT22, but I don't think so. So let's just get into this lesson, which is volume and surface area of spheres. And this should be not too hard. Okay, so I'm going to start talking about volume. And to be able to talk about volume of a sphere, you have to talk about volume of a cylinder first, okay? So think about it as a cylinder that is perfect so that just one sphere or one ball fits into it, okay? And so it's one of those things like if they sold tennis balls in one of these. I know that they sell 3 tennis balls in a cylinder kind of container, but think about it like if they sold tennis balls in just one unit, okay, which is dumb anyway. But sometimes they do that for golf balls, which is weird. So let's actually think about it as golf balls, if you've seen it. So there's a golf ball that it's in a cylinder. I know it's not perhaps a cylinder, sometimes it's a cube, now that I think about it, but let's say it's a cylinder in this scenario. Okay, so we know one thing, that there's a radius here in the cylinder, and obviously that radius is the same radius for the sphere. So it has the same radius for both. Oh yeah, it has the same radius for both. Now, if it has the same radius that way, well, in a sphere, it also has the same radius this way, and so this has to be another diameter. So we have a diameter here for the height and a diameter here for the diameter. Duh. And the diameter is the same for both, right? So far so good. So the diameter is 2 radius, and this is 2 radius. Okay, so let's find out the volume of the cylinder. Okay, because that one we know. What is the volume of the cylinder? The volume of the cylinder is going to be volume of the base times the area of the base. Sorry, area of base times height, or volume equals big B times H, right? Area of base times height. So the area of this base, it's going to be, what is the area of a circle? The area of a circle is radius, pi radius squared, sorry. Pi radius squared. Oh yeah, pi radius squared. Times 2 times the radius. Why 2 times the radius? Because the diameter is 2 times the radius. So that would be the volume of the cylinder. So the volume of the cylinder would be 2 times pi times the radius cubed, because radius squared times radius is going to be radius cubed. So I found the volume of the cylinder. The cylinder is going to be volume equals 2 times pi radius cubed. All right. But that doesn't really tell us much. Well, it does tell us something. And you have to be careful about this. What it tells us is that this volume right here, in which the sphere fits, it's 2 times pi times radius cubed, which is a little bit bigger than what we have. All right. So what about the sphere? Well, the sphere doesn't cover, it's not like a cone or a pyramid, because it doesn't fill the whole cylinder, but it doesn't fill 1/3 either. I mean, there's certain things here that still fit a little bit, right? It fits a little bit. It's still in there in the cylinder. And so what we're going to say, it's like, I don't think it's 1/3. It's going to be 2/3. Okay. So the volume for the sphere, it's going to be 2/3 of the volume of the cylinder. It's going to be 2/3 of the volume of the cylinder. So the volume of the sphere is going to be 2/3 times 2 pi radius cubed. It makes sense, right? Pretty easy. But now we have to actually make it all into one. And so what is 2/3 times 2? Well, 2 times 2 is 4, and 3 times 1 is 3. So the volume of the sphere, and this is actually the formula that you have to memorize, is 4/3 pi radius cubed. That's how we find the volume of a sphere. 4/3, and I'm going to write it again, see if it's dark enough for you to understand. Radius cubed. Let me get a peek in there. Oh yeah, volume of the sphere, 4/3 pi radius cubed. And it makes perfect sense, right? So let's move on to example number 1. Okay, in example 1, we have a sphere with a diameter of 20 centimeters, and pi, obviously we're going to use 3.14, and they tell us, well, what is the volume? Question mark. So step 1, know our formula. Volume is 4/3 of pi radius cubed. Yay! Now, what is radius? The radius is going to be 10, because my diameter is 20, the radius is 10. So volume is going to be 3/4 of 3.14 times 10 cubed. Right? So far, so good. What is 10 cubed? 10 cubed is the same thing as 10 or 1 followed by how many zeros? The number of the power. So the number of the power, the exponent is 3, so it's going to be 1 and 3 zeros. So it's going to be volume equals 3/4 of 3.14 times 1,000. All right, and 1,000 times 3.14, it's going to be moving the decimal place how many times? 3 times, because of the number of zeros. So the volume would be 3/4 of 3,140, 3,140. Now, let's divide by 4 and then multiply by 40. It's easier that way, okay? Let's divide by 4 and then multiply by 3. I don't know why I said 40. Maybe because of this 40 here. So let's divide by 4. 3,140 divided by 4. Is going to be 4 into 31 is going to be 7. 28. And into 34 is going to be 8. 32. And into 20 is going to be 5. So volume is 3 times 785. 5 times 3 is 15, and a 1 goes up. 8 times 3 is 24, plus 1 is 25, and a 1 goes up. 7 times 3 is 21, plus 1 is 22. 2,255 centimeters cubed. Now let's check the answer with the book. Not even close. Where did I go wrong? (3,140 centimeters and 4/3). This is where I went wrong. You see here, that's why you need to check. 4/3, but then I put 3/4, 3/4, 3/4. Oh, it's because I didn't find the right fraction of it. It's 4/3, not 3/4. Whoops, egg on my face. Okay, so we could have just left the 3,140 divided by 3, not 4, but by 3. And so it's going to be 1, 0, in 14 it fits 4 times. And in 20 it fits 6 times, 0.6 bar. So it's going to be about 1,047. It's about 1,047. And then we're going to multiply them by 4. And so 4 times 7 is 28. And a 2 goes up. 4 times 4 is 16. Plus 2 is 18. And a 1 goes up. And then so 4,188. Is that even close? Yeah, that's actually closer, because the actual answer would be 4,186 and 2/3, which is 4,187. But because I rounded up this number, this makes sense. And so it will be about 4,188, or your book says 4,200. 4,200. And that is how you do it. So please make sure that you don't forget that this is 4/3, not 3/4. Don't make the mistake I made. 4/3. So again, the formula is 4/3 of pi radius cubed. Now let's do surface area, and that would be it for this lesson. Okay, so area of a circle, right? The area of just a circle, not the sphere. The area of a circle is pi radius squared, right? Everybody knows that. But what about the surface area of a sphere? To find the surface area, what we need to do is understand that this shape is made out of many circles. And so in here, I divided into 4 circles, right? Into 4 parts. This is 1, 2, 3, and 4. And if you don't actually know, when you actually look at those 4 parts, if unfolded, they would actually look kind of like, I mean, if you peel an orange or something like that, and you do it like that in fourths, when you flatten them out, they kind of look like a certain type of circular shape. And believe it or not, those are actually circles. The thing is that this is called non-Euclidean geometry, which is actually circular or spherical. And non-Euclidean geometry is something that it's a little bit hard to comprehend because it's in a sphere. It's not flat. We tend to look at the world and everything is flat. That's why some people actually think that the world is flat when it's not, or the earth is flat when it's not. But understand this. If we actually we're able to flatten it out completely into perfect circles, it would actually be 4 times the area of a regular circle. So 4 times the area of a regular circle would make the surface area of a sphere, and that's all you need to know. Because in example 2, they tell you the diameter of a softball is nearly 10 centimeters. So this diameter is 10 centimeters. Find the surface area of a softball, and once we have to do it in terms of pi, and then we have to use our good old 3.14. Yay! So, area with pi. Pretty easy, because then the surface area would be 10 is a radius, 10 squared is 100, 100 times 4, well, let's actually write it out. 4 pi 10 squared, right? 10 squared is 100, and 100 times 4 is 400. So it'd be 400 times pi. Whoops. 400 times pi. That would be our surface area in terms of pi. But now, what about 3.14? Well, our surface area then would be 400 times 3.14. What I'm going to do is I'm going to multiply 3.14 times 4. And because it's 100, I know I won't have any decimal numbers. So I'm just going to do 3.14 times 4. And not 3.14, but 314 times 4. So 3.14 times 4. 4 times 4 is 6, and a 1 goes up. 1 times 4 is 4, plus 1 is 5. And 3 times 4 is 12. Our surface area is going to be 1,256. Oops, forgot centimeters squared in both centimeters squared. Now let's check with our book. I did it right for my example, because in my example it said that it was 10 centimeters for the radius. What I didn't realize is that for the example in the book, it's going to be 5 centimeters for the radius because the diameter is 10. Well, then I solved my example right. I'm 100% sure I can do this one again. Because it'll be 4 times 25, which is 25 pi. And that obviously it's going to be 100 pi centimeters squared. Hooray! Because 4 times 25 is 4 quarters equals $1. And in here, then, it would be 100 times 3.14, which makes the whole thing even easier because it's just 314 centimeters squared. And that's it. That's it for this lesson. So just make sure that you pay attention to the problems and don't make your own problems, because that's exactly what happens. We all are experts in answering our own questions, but those are questions that people don't usually ask. We need to make sure that we answer the questions that they are asking, not the questions that we want to answer. So yeah, that's it. And so that's it. Thank you again, and I will see you in the next one.